Welcome to the IM2 video lecture. This is going to be covering solving an equation by using the square root. The learning target here is for you to understand how to solve an equation by taking the square root. Here are three success criteria. One, you should be able to know and when you do not need to factor to solve the equation. Two, you need to be able to use the square root to solve for an equation. And three, you need to realize that there are two solutions when you take the square root. Let's explore this. We're going to look at when to factor and when not to factor. Notice number one and notice number two. What do you notice or what do you wonder about this problem? You should notice that this one on the left hand side you need to factor. The reason why is because it's technically in standard form. It's ax squared plus bx plus c. On the right hand, right? We ask ourselves, but why do we need a factor? The reason why is because of that bx term. This is what's causing us for it to require us to factor. And in that process, we can use the diamond method. And in that process of the diamond method, we get these factors x minus 4 times x plus 1. We could also get the solutions here by setting the factors equal to 0. So it becomes x equals to 4 and x equals to negative 1. On the right hand side, you do not need to factor. Why? Because that bx is 0x. There is no bx term. It's a missing term. It's not there. And in that process, you can basically solve. To do that, you just add 4 to both sides. And in that process, you're going to get x squared equals to 4. Square root both sides. In that process of the square root, you're going to see that the square root and the squared will cancel out. That's why the next step was x equals to the square root of 4. The square root of 4 has two answers, a plus 2 and a minus 2. So you would say that x equals to 2 and x minus 2 are the solutions. Notice this is one solution and this is the second solution. When you take the square root of something, there's always two solutions, a positive and a negative. So here you should see now the difference between an equation where you need to factor versus an equation where you don't need to factor. Let's review the core concept of the square root property. What two same numbers multiply together to make the number 9? We can say the number 3 times 3, or 3 squared will get us 9, or we can multiply negative 3 times negative 3. Negative 3 times negative 3 is the same thing as negative 3 squared. That also equals to 9. So notice there are two answers here, are two numbers that you can multiply together to make the number 9. So if you take the square root, which is the inverse of squaring, so let's take the square root of 9. You get 3. Let's also take the square root of 9. You can also get negative 3. So there are two possible answers that come out of taking the square root. This is the definition of the square root property. When you take the square root of a positive number, like 9, there will always be two values, one positive and one negative. That is indicated by this symbol of plus minus. So if I say the square root of 9, that will be equal to plus and minus 3. That makes 3 and negative 3 as the solution. Here is the core concept from the book with a more academic definition. There are 4 examples that we're going to go look at when it comes to solving the square root to solve the quadratic equation. Number 1, let's take a look. So step 1 is always to write the equation. 3x squared minus 27 equals to 0. Okay, you want to isolate the x by itself, so first of all we're going to add 27 to both sides. As a result, you get 3x squared equals to 27. Then you want to divide by 3 to both sides. In that process, you get x squared is equal to 9. Afterwards, you're going to now take the square roots of both sides, leaving you with x is equal to plus and minus the square root of 9. The square root of 9 is just 3. So the solutions here are just x is equal to 3 and x is equal to negative 3. Let's look at number 2. X squared minus 10 is equal to negative 10. First, always rewrite the equation. Now we're going to add 10 to both sides. You get x squared is equal to 0. Notice when you take the square root of 0, in that process, you just get 0. Please notice that the only solution to the square root of 0 is 0. There's only one solution. What about number 3? Negative 5x squared plus 10 is equal to 16. So, there should be an 11 here. Right? So, let's subtract 11 to both sides, getting you 5 on the right hand side. 16 minus 11 is 5. And on the left hand side, it's negative 5x squared. Divide by negative 5 to both sides. You get x squared is equal to negative 1. Now, you would want to take the square root, but an issue arises. The square root of a real number cannot be negative, so the equation has no real solutions. Yes, there is a chance that you can do imaginary numbers, but for the sake of this lesson, we would say that you cannot take the square root of a negative number because you're going to get imaginary solutions. So there are no, here you would say that there are no real solutions here. Lastly, this is another possible way you will see using the square root to solve for the quadratic equation. First step is always to rewrite the equation. Now you're going to take the square root of both sides because you're trying to get rid of the square. In that process, the square root and the square cancels out, leaving you with x minus 1 on the left hand side. On the right hand side, the square root of 25 just becomes plus and minus 5. So you could say that now you want to add 1 to both sides. Okay? You will get this. Y is equal to 1 plus and minus 5. There are two possible answers here. This is going to be the addition solution, where you add the 5. This is going to be the subtraction solution, which is going to be minus 5. So notice here your solutions would be 6, because 1 plus 5 is 6, and 1 minus 5, which is negative 4. That's your other solution. If you graph this to double check your answer, you would see that the solutions would be right here, where x is equal to negative 4 and x is equal to 6 here, if you graph it on decimals. So the zeros here are negative 4 and 6. You could also say the solutions are x is equal to negative 4 and x is equal to 6. All right, so there you go. Those are your example problems. Here I can show you a couple of practice problems, but they mirror the example problems. Like the first one, you can do it's negative 3x squared is equal to negative 75. You can divide by negative 3 to both sides. You get x squared is equal to 25. Square root both sides. Okay, you get x, which is left over, is equal to plus and minus 5. All right. Let's see, if we do 3, we add 15 to both sides. Notice this automatically becomes 0. So 4x squared is equal to 0. Divide 4 to both sides, you get x squared is equal to 0. No matter what, even if you take the square root of 0, you're always still going to get 0. Lastly, let's do number 6. Okay, let's just write it first of all. 2x plus 1 squared is equal to 36. So square root both sides just to get rid of the squared, leaving you with 2x plus 1 on the left hand side and square root of 36 on the right hand side. The square root of 36 is plus and minus 6. Subtract 1 to both sides, you get 2x is equal to negative 1 plus and minus 6. Divide 2 to both sides. Your answer is x is equal to negative 1 plus and minus 6 divided by 2. Those are your two possible answers, right? So these are some practice problems that you can see that mirrors our section of using the square root to solve for the quadratic equation.